So in this video, I'm going to talk about the heck reaction, and the mechanism is not what we need to know. The mechanism is, I doubt your teacher will require you to memorize it, but what we should know is what we produce. And the idea is that we usually take an aryl bromide, okay? So we take an aryl bromide and we add some sort of alkene, okay? We add some sort of alkene. In this case, I'm going to use styrene. Okay, this is styrene. Okay, this is styrene, and here's the reagents that we use. We use palladium acetate and triphenylphosphine. And triphenylphosphine and triethylamine. Okay, and what we generate is a terminal carbocation that the bromine will attack, and the reaction goes from there. But what you should know is that we're going to get end-to-end addition to the carbon-carbon double bond. So therefore, the product for this reaction will look something like this. Okay, so this will be the product that I get. Notice that I'm getting end-to-end addition, so I will lose my bromine and I will get end-to-end addition to the alkene bond. Okay, now what about this one? Okay, if I take this aryl bromide here and I add, let's use styrene again. You know what, let's use this. Okay. What do I get? Again, we got to react this in palladium and acetate, triphenylphosphine, and triethylamine. Okay, again, we get end-to-end addition. Okay, so we're going to form the product. This carbon is going to be bonded to my alkene bond. Okay. It has this. So notice all I'm doing is forming sp2 carbon-carbon bonds. I'm just adding on my carbon on the benzene ring to the alkene bond. That's all we're doing. Okay, so maybe we could look at another one. So if we take this molecule and let's use propylene, okay, and we take this and add palladium acetate, okay, triphenylphosphine, okay, and we add triethylamine, okay, we'll get this product. Okay. My carbon is going to be bonded to my terminal carbocation that I will create. Now I'll get this. Now this is called anethol, and you'll usually see these in anisole oils. All right, so we know anisole oil is used for flavorings. Okay, so this is the product that we get. So all we're doing is adding end-to-end addition using an aryl bromide. Okay, maybe we should look at one more example. So if I take this molecule, okay, and I react it with this. Triphenylphosphine, and triethylamine. Okay, what will be my product? Well, since we have two alkenes. To have two alkenes, you actually generate two carbocation. And so what you'll find out is that this will end up happening twice. So this will add twice. So the product of this reaction will look something like this. We have our CH3, we have our CH3. This will be the product that I would get. Now, does it matter what's inside here? No. All we care about is the fact that we have a terminal, we have an aryl bromide, and we know we're going to use the carbon of that to attack the plus charge, and we have our reagents. That's all we care about. Now, this is a polymer. Okay, so this is a polymer. This is a polymer. Okay, and in fact, this is actually cyclotene. Okay. So this is cyclotene. Now this chemistry has been it's very new, and the guy actually won a Nobel Prize. It's very new. And this is a chemistry they used to make a leaf. Okay. You know, a leaf in Walgreens. Okay. It was a chemistry used to make a leaf.